Hello, let's talk about populating next right pointers in each node too. So you're given a class node, and this is written in C language, right? But it doesn't matter. So the idea is you have to point your each level at the end. You have to point at the node, and then if you are in the same level, you have to point on your following node. So this idea is pretty much like prefer search. So I'm going to use the easy way to do it first, and if I have time I will just um, uh, record another video for the harder way. And the easy way is actually uh, using a queue to store the node, and then for each level you just point your next, because you have left and right and next, right? Just point your next to the next level, I mean next node in this level. So I'm going to say if root equal to no, and I'm going to return no. This is the base case, and I need a queue, right? I need a queue. I need using a linked list, and I'm going to offer. I'm add to the queue. I'm going to check. I'm going to traverse the tree, right? So if I want to traverse using breakfast search, and by using queue, you need to know it's definitely queue that is not empty. Then what I would return, I would just return root, because I would just keep changing the pointer for each node. I'm not going to modify anything. So so for the current level is the level 1, which is node 1, right? So I'm going to say in size equal to q dot size, and then I will have to traverse the size, the current size of the queue, and I will just go on the next level. So the reason why I'm using the in size is because when you offer or when you pull, right, you do affect your size. And if you have children, then you are not supposed to say, okay, for in I equal to 0, I less than q dot size, because this is actually dynamic changing, and then this is not good. And I need a 10 pointer. Okay, I'm going to say why I need a 10 pointer for this. So imagine like imagine there's a domino in front of each level, and then you just point at your next, which is the current one. So the current one is this no current equal to q dot pull, and say temp dot next is equal to current, and then current is temp equal to temp dot next. So I'm actually like changing the next pointer, right? I'm going to modify the node dot next, not the actual value, right? So okay, so if I do think about if current do have the children on the left, it's not no, then I would just add into a queue, right? So okay, queue dot offer current dot left, then that's a right. So if current dot right is not no, then I just add into the queue, and at the end I'll just return the root. So you don't have to think about like how do you actually read a punch punch symbol. So this is actually when you read it is no, and then you just print it print a punch symbol. So this is the solution, and they just run it and see if I have any typo. Yeah, I do. Okay, let me rerun it, and it's okay. Okay, I passed the test. So this is the easy way, and I'm going to talk about how to explain the time and space complexity over here. So the time is actually all of them. You have to traverse every single node, definitely, right? So time complexity is all of them. Space is all of them, because you store every single node into the queue, and it doesn't matter like you pop or over, because when you add into the queue, that's how many times you have to add into the queue, right? So that will be all of them. And this will be the solution, and this is the preferred search solution. And it is the simplest way, but the time and space complexity is all of them. And if I have time, I will just record another one, and the space will be all of one, but not for this video. So if you feel it's helpful, leave a like, subscribe if you want it, and then leave a comment if you have any question, and I will see you next time. Bye.